AI research and the research library. AI is it's everywhere. Research libraries are at the forefront of exploring how AI can responsibly be used to explore and engage with our collections and our services, both to enhance discovery, but also to demonstrate our role as partners and leaders in the wider research ecosystem. Today's extended Digital Shift Forum, so this is a 90-minute session, will examine the opportunities and the challenges of AI research and the research library in two key areas. So we'll look at AI and collections, so how research libraries are using AI and AI tools to explore, to engage, and to connect their unique connections in new ways, supporting research and enabling innovation. And the second way we'll be looking at this is through AI and research support. So how are libraries using tools and platforms that underpin our institutional research activities, from research information management and metrics to enabling open, transparent, and responsible approaches to research culture and evaluation. So very excited that we've got colleagues from two universities talking today. So my university, University of Manchester, and the University of Cambridge. They will be considering the opportunities, challenges, ethical implications, and how the role of the research library is evolving in this AI-enabled world. So I am going to hand over first to my colleagues at the University of Cambridge. We've got Twan, Amelie, and Jenny. And I will hand first to Twan.
Hello, thank you, Kieran. To start with, I think we all have the same common problems in terms of challenges in terms of AI. So I think at Cambridge, to be fair, I think we started kind of slow. We kind of hanging back, but we have the same problem, right? We've got so many different AI, LLM releasing, leapfrogging each other. Lots of social media, people hearing about it, people being curious, skeptical, scared, confused. They don't know which one to use. They don't know anything about how to write prompts. And there's also a lot of negatives, kind of sentiment as well. The usual highly unethical or massive environmental impact and so on. So at the same time, we also have some practical things that we wanted to solve. So one of the use case that you will see later is around things like we've got a vast amount of card index catalog, right? So these are on card handwritten type, varies over the years, and they're fading. And you have the same risk of if something happens to them, we've lost because you have no idea what we have. So practically, you've lost all those books and journals and everything. So we were looking at a project to see how we can use AI to solve that particular problem. And then came the opportunity from AI@CAM, which is an initiative at Cambridge-wide, university-wide initiative to try to introduce AI into various aspects. So we proposed a project to do this, particularly the use case particularly, and then along that came opportunity to collaborate with others, and then that's how this project Arch came about, which then I will hand over to Emily to cover the rest of the details. Thank you.
So yeah, thank you for that brilliant framing of the project and what we're trying to do, Twan. So hello everybody, thank you for joining today. I'm Amelie Roper. I'm Head of Research at Cambridge University Library. I work in the University Library Research Institute, which is a department within the library. And following on from Twan's introduction, my colleague Jenny and I are going to introduce you to the Arch project in a bit more detail. So over the next half an hour or so, I'll tell you what Arch is. I'll describe the work we've been doing on the case studies that underpin it and share some interim findings. And then I'll pass over to Jenny, who's going to demo the hub for you. The project is midway through, so all of what we will be talking about is very much a work in progress. So what is Arch? So Arch stands for the AI for Cultural Heritage Hub. It's a short research project to create a workspace, the hub, and a community of practice that will enable non-technical users to analyse cultural heritage data securely with AI tools. So by non-technical users, we mean practitioners working in galleries, libraries, archives and museums, and academics working with cultural heritage collections. And by cultural heritage data, we mean data about the items held in our collections. And as you'll be really very well aware, the most typical data types will be metadata or descriptions of the items in our collections and digital images of them. So when we talk about Arch or the hub, we mean two things. Firstly, a secure workspace or a platform built using open systems and standards that could potentially be replicated by other organisations. Users can log in, upload their own cultural heritage data, and experiment with AI tools that meet their use cases. And secondly, we mean a community of practice to support the use of the hub. So this idea of creating a secure workspace is a key aspect of our project, as lots of cultural heritage data is sensitive for reasons we all know, such as copyright, data protection, and outdated or offensive language. So we wanted to create a space where AI could be used on cultural heritage data without that data being retained by AI engines and exposed outside of the hub. And this is achieved by the hub interacting with models via APIs that guarantee data will not be used for training or exposed. So when is the project running? So it's running now. It's a 14-month project, which finishes at the end of March 2026, as Tuan mentioned, with funding from AI at CAM. So it's a short experimental proof of concept project rather than an attempt to build a really polished hub. So an important aspect of Arch is that it's drawing together expertise from many different disciplines: cultural heritage practitioners, so librarians, archivists, catalogues and curators, digital humanities specialists, AI experts, developers and academics. So it's a really collaborative project led by the University Library, Cambridge University Library, but also working with the Maths Department and the university's Collections, Connections, Communities Strategic Research Initiative. And we're also collaborating with researchers at Birkbeck and Liverpool and have an advisory board with representatives from across our sector, including RLUK. So you can see a few of the team pictured here, but in total there are about 16 of us working on the project. Okay, so now to the why. Why are we building the hub? So I've already mentioned concerns around data sensitivity, which mean that many cultural heritage practitioners, including staff at Cambridge, are really reluctant to use openly available AI engines on their data. But there's actually a much bigger reason why Arch is needed that's probably all too familiar to a lot of us. As we know, across the world, there are billions literally of items in galleries, libraries, archives and museums that can't be accessed. And there are lots of different reasons why this is the case. But two key ones are firstly that these items are not discoverable, so there are no publicly accessible digital descriptions of them. And secondly, that if they are discoverable, the items are in formats that do not meet users' needs. So we believe that AI can help to address some of these barriers, therefore making this content more accessible for research, but also lifelong learning and enjoyment. And now a bit on how we're developing the hub. So we're using 6 case studies, drawing on 5 Cambridge collections, and each case study addresses one or more of the following challenges. So unlocking inaccessible data, reassembling fragmentary and dispersed cultural objects, and integrating expert cultural knowledge into AI algorithms. Now to what the hub can do. So the key things that it can do are it can transcribe handwritten, printed and typescript text, including documents with quite complex layouts. It can create and enrich metadata. It can undertake text and sentiment analysis. It can label images and analyze them. and it can generate text from audio. It also includes how-to guides for common use cases and utilities to assist with using the hub, for example, converting PDFs into image file formats, which is what the hub needs to process data. And you'll see some of these things shortly when Jenny demos the hub. I'm now going to say a little bit about how we're organising the project. So the project has 5 work strands. The first is connected with developing the hub, so requirements gathering, building the hub and refining it. The second is documenting what we're doing in terms of workflows, how-to guides, and the process of developing the hub. And the third is working on our 6 case studies. The fourth is forming a community of practice around the use of AI on cultural heritage collections to enable us to learn from and support each other. And finally, we're gathering structured feedback on the hub through note-taking at events and feedback forms and interviews. In terms of outputs, the things we will produce are the prototype hub, the guidance and workflows built into it, the community of practice underpinned by a mailing list, code, workshops, and written outputs such as presentations, blog posts, and journal articles. And in terms of outcomes, we hope that our case studies will have improved the discoverability of selected collections in Cambridge, and to have done that using the methods that will be extensible to other collections. We also hope to have generated new knowledge about the collections we're working on and to provide a foundation for new research. And finally, we hope to have developed a greater level of AI literacy among cultural heritage professionals and academics. So I'm now going to talk in a bit more detail about 4 of the 6 case studies that we're working on. So the ones that I'm going to talk about today are the card catalogues case study at Cambridge University Library, the accession registers and notebooks case study at the University Museum of Zoology, the Book of the Dead at the Fitzwilliam Museum, and the Mesoamerican Pictographic Lectionary at Cambridge University Library. So, first of all, to the card catalogues case study. I imagine that I probably don't have to explain to this audience what the problem is and why we might need to solve it. But briefly, at Cambridge University Library, we have, I want to say tens of thousands, but it's actually more like hundreds of thousands of items that are only recorded on cards. It was a real priority for the librarians on the project team to explore the use of AI tools to transcribe catalogue cards and see whether we can use these tools to generate reliable metadata that we can incorporate into our online catalogue. We've had some really good preliminary results in using large language models to generate data from scanned cards and structure it into a usable form. We held a successful workshop on this with different types of materials back in September and are now forming an internal card catalogues working group. We're also working to test the use of AI to transcribe and structure card catalogue data with a particular subset of materials, so music materials, and are beginning to do some focused work on workflows. So our second case study is based at the University Museum of Zoology, but is actually more like an archival project. The museum is just over 200 years old and has paper accession registers and notebooks documenting the provenance of its specimens and the circumstances of their collection. These records are not just vital for the museum in understanding and documenting its collections. They also hold crucial yet inaccessible data on climate change, biodiversity loss, and the effects of empire. If they can be made accessible and searchable, which they aren't at the moment, they have the potential to enhance research of enormous global importance. So the question here was, could AI help with the transcription of these handwritten documents and organise the data into a structured and searchable format where it could be of use to museum curators and external researchers? This case study is serving as a proof of concept for the museum to explore various ways of generating metadata at speed. And this is really important to them as they're going to be involved in the forthcoming Distributed System of Scientific Collections Digitisation Initiative, or DISCO. So in May, we worked with the museum's curators to run a workshop bringing together practitioners and researchers to test various AI tools and assess how they coped with these tasks. One issue is that the data, which was already structured on paper, like the registers that you can see here, was much more challenging for AI transcription than straightforward or lightly structured prose, such as correspondence. So on the images here, you can see some of the complexity of the layout, the structure, and the handwriting. You can also see a sketch of a bird in the register, which has then gone on to be used in museum publicity. So through that workshop, we learned hands-on about the value of breaking down a task into stages, pre-processing the images to make the text clearer, separating out the layout and structure of text from transcription, and refining our prompts. The museum curators particularly appreciated the security of working within the hub. The early records are from a time of imperial and colonial acquisition, and some of the language they use is offensive. Curators need to be able to work with the transcriptions of the documents first and review their content before sharing them more widely. So after the workshop, the museum followed up by focusing on the most structurally straightforward material, that is, the lists and letter collections that they hold. Volunteers are now scanning letters, using AI tools within the hub to transcribe them, and then reviewing the transcriptions. We're planning to generate some data on using the hub to transcribe letters and how this compares to a completely manual process in terms of accuracy and the time it takes. So now on to case study 4. This is exploring a very fragmentary papyrus roll, the Book of the Dead Ramessay, at the Fitzwilliam Museum. It's a partnership with the curator of Egyptology at the Fitzwilliam Museum, Helen, and a papyrus expert at the University of Liverpool, Joel. The question is whether AI tools can assist in determining the placement of various unplaced fragments from this papyrus. I think of it as like doing a huge jigsaw puzzle, but it's much more complicated than that. It's not enough just to look at the edges of the pieces and try to join them together, since first of all, we don't have all the pieces, and secondly, the ones we do have weren't neatly detached from one another. In theory, this should be a suitable task for multimodal AI models, since it involves processing large amounts of image data and using prediction and pattern recognition. The first task was the painstaking one of imaging all of the fragments, over 3,000 of them, which we did over the summer. Our AI expert from the maths department, Wallace, has then started to train a model using a subset of these images, plus existing metadata. As well as the text and images, he's training the model to look at the pattern of the papyrus fibres. Combining different types of information offers a better chance of it suggesting suitable matches. And having Wallace design a bespoke model like this, working closely with the papyrus experts, enables him to test and refine the data and keep tweaking the algorithm to get a better result. Looking at the fragments so intensively during the process of the imaging has already told us something. Joel has proposed that what we have is actually made up from 2 different books. So we can feed that information from his observations of the images into the model. So it then becomes an iterative and collaborative process of review, suggest, and tweak. The last case study that I'm going to talk about, case study 5, I'm pleased to say, is pretty much complete. It's focused on a 16th century manuscript from the Bible Society Library, which is housed at Cambridge University Library. The manuscript is a lectionary written in Latin and the Aztec language Nahuatl. It was written in Mexico in a Christian missionary context, but probably by indigenous scribes. This case study was led by one of the Mumby Fellows embedded at the library last academic year, Josh. Josh had several research questions which we thought could be used to test out AI models. So, the first question was to investigate the decorated letters in the manuscripts and compare them with the wider corpus of Mesoamerican glyphs and pictographs from other similar digitized manuscripts. Could the model suggest similarities that scholars hadn't noticed and help uncover connections between pre-colonial and colonial linguistic and visual elements? And here we can see some examples of the decorated letter I in the manuscript, whose designs mirror both Mesoamerican and European symbolic traditions. The other question related to what Josh has dubbed Aztec Tipex. This is white paint used to erase textual elements, many of which were written over. It was a painstaking process to try and identify all the examples throughout the manuscript as part of determining which of the many hands in the text were using the white paint. We wondered, could an AI model be trained to identify the white paint in the digital images to speed up the process? So Josh worked again with AI expert Wallace to train bespoke models, and the results were really promising in relation to tracing the Tipex passages. It's also worth noting that AI was one of a number of research methods that Josh used to investigate this question. He also used multispectral imaging and pigment analysis, as well as traditional paleographical skills. There's a whole combination of different methods alongside AI being used to address this particular research question. So what have we learned so far? So one of the key findings is how important our multidisciplinary team is in creating a hub that will actually function well and be useful. At the beginning of the project, I was really aware of the challenge of all the different people and collections that were involved and the need to draw these things together to make a cohesive project. But as the project progresses, this is emerging as one of its greatest strengths. We're also finding that some of the workflows from our case studies sit really neatly inside the hub, and some others are best sitting outside of it, with the hub concentrating on the more common use cases and perhaps containing some guidelines or notes on the specialist or less widely applicable methods. So, for example, the work that we're doing on the Book of the Dead most likely will sit outside the hub, but the hub's documentation section will include links to blog posts or articles about the methodology and findings. Since we applied for funding in Cambridge, and I imagine in your organisations too, there have been lots of initiatives to encourage the use of AI in business operations, so to help with daily work tasks. One of the things we found is that our project has had some overlap with this, particularly in terms of the work we're doing on card catalogues. And this has led me to reflect on what is the value of doing this type of work in the context of a research project. In addition to funding, approaching this as a research project, I think, offers a focused opportunity to explore this systematically, to work across disciplines and expertise rather than just within the library, and to have richer results for that, to write up and publish findings, and perhaps to have the freedom to be a little more experimental. We hope this talk will leave you wanting to know more. If it does, there are a number of ways you can keep in touch with us. You can join our mailing list using the QR code or link on the slide. That's a good way to find out about project events and updates. You can also check our website and contact us by email. And now I'm going to stop sharing and pass over to Jenny for the live demo.
So this is the hub that we've developed. I'll very much emphasize that this is a proof of concept. So in the early stages of development, and it's a kind of ongoing project. But it's starting with hooking up some available tools that are there's a lot of AI tools around available, but it's not always clear where to start. So what we wanted to do with this tool is to provide a playground to allow curators, non-technical users, but subject experts in galleries, libraries and museums to come and try out, have a safe space where they can try out different AI models and see what works for their data, because they're the ones who know the data the best, and then they know how to interpret the results. And it's also giving the power over to them to try out different models available. So that's the idea behind what we're doing with the hub. And this provides you a space, an individual space to upload files, and the tools that we've provided are listed. Some of them are there, and we've also got a how-to section which will populate with more of the information from the use cases that Amelie's been talking about. The use cases that have been the hub has been used for are the card catalogue use cases and the zoology registers use case. So focusing a lot on trying to extract data from text. We've separated the tools into two different categories, multi-file tools, which I'll get onto later. But single file tools is what I'll start with. These tools have been selected because they are easy to wire up in the first instance, rather than particularly tailored towards cultural heritage use cases. But we want to extend this idea so that as new models became available and new tools become available that are more tailored towards individual use cases, we'll be able to expand the offering with whatever's appropriate as we develop our needs through workshops and real life use cases. So I'll start off with the Amazon Textract tool. And this is an OCR tool, which I'll start with one of Cambridge's letters. This is a foreword on the Origin of Species book. This is, I have no doubt, the first copy of the Origin of Species to reach my father's hands. And that was from his son, Leonard Darwin. So it's quite a nice example of handwritten text. So we can extract the text data here. This will vary depending on the language used, different character sets, but I think you get an idea about its capability to pull out content, lines, and polygon information from the text itself. So it provides a very user-friendly interface to try out these different tools. This one is called Amazon Recognition, and it's around assigning labels to different images. So I will try out initially with a picture of a cat from our Darwin collection. And it's a beautiful drawing of a cat there. I'll see how it does. And this one, it does rather well. It does art, drawing, animal, cat. And you can see it assigns a confidence rating as well as to how certain it is that this is a piece of art. But it doesn't always do so well. I always like to show an opposite use case. So this is another picture of a cat, also from our Spanish collections this time. Fantastic expression there, but it doesn't do so well on this example. It detects its art, animal, wildlife, zebra. So you can see that its results vary very much depending on what content you're feeding it. You can see it's got stripes, perhaps that confused it. There's also a identify language and sentiment from an image. So this provides a way of evaluating the text to see if it's overall positive, negative, or neutral, and also pulls out some semantic meanings, people, place names, dates as well, and some other information from the text. So I'll try the same document that I previously analyzed. So we'll see this. This uses Amazon Textract to extract the text from the image, and then Amazon Comprehend to identify meaning and key phrases. So it's identified the language as English. The sentiment is neutral overall, and it's been able to pull out people, dates, quantities, etc. So some key information there. We've also got tools for identifying facial features and audio from text. Again, not as applicable to some cultural heritage use cases, but since they were easy to wire up, they're there at the moment. We've also got a set of tools that Amelie mentioned around people came to use the hub, but didn't necessarily bring files of the right format that these AI tools expect. So if they're bringing TIFFs, it may not be able to accept TIFFs or PDFs. So we've provided tools to allow them to transform those into a format that they're able to then play around with the tools with. But most of the development time was looking at a batch processing tool. And this allows you to try out different OpenAI models, which is the model behind the ChatGPT. So it's got, at the moment, different versions of that, but we want to expand it to try out different tools are available in the same interface. When we use this for card catalogues, I'll show you an example of how we were processing that. If I show you some of our secondary legal deposit material, this is an example of catalogue cards, and I love this example because they're both handwritten text, typed text. They've got varying amounts of information, and they're very real. They've got people's feet in, and they've got, some of them are upside down. So it's good to see a good variety of realistic images there rather than studio captured perfect images. So this provides an interface where you can process batches of information at a single time. So in this case, I'll select 4 of those card catalogue images. And in my prompt, I've asked for it to pull out things like title, author, class mark. So I'll launch that going. So it will be able to pull out that kind of information, and I've asked it to display it in a markdown table. But you can see, you can select different models and different batch sizes, and also we've enabled you can toggle on a web search to, if you want to pull some information from the web. But this tool provides much more interaction as far as things you want to do with it. It's not just about catalogue cards. You can do any kind of, we've looked at identifying different different hands in different writing, and looking at, it's also been quite helpful in trying to read text that is can't necessarily be read by kind of non-experts in the field. So that's been quite useful for people transcribing content as well. So fingers crossed this will come back in a few seconds and show you a table of title, author and class mark for the catalogue cards. I'll give it a second to do. So you can choose the different output formats as well. You can have Markdown, CSV, HTML, etc. So this has got the table, and it's pulled out the title for these different records, the author, class mark and description, etc. We're very aware that this may not be, this may not be perfect. This may be interpreted wrong. There may be some hallucinations in the text. This is something that is designed to get you part of the way through processing. So it might help in some of the transcription to get you 80% of the way there, but we will need a human phase to be involved and review the content before it's been able to be ingested to any catalogue. So I will stop there, I think, and can answer any questions.
Thank you, Jenny.
Brilliant. Thank you, Jenny, Amelie, Tuan. That was wonderful to see real life examples of AI in use. I think we've been talking about it a lot, but to see practically how you are using it on your collections is incredibly inspiring. So I'm going to dive straight into the questions. So Claire Knowles from Leeds asks around, can we take what you're doing with the hub and sort of transpose that model? It looks like you're collecting a lot of information about how you're kind of setting it up. I think we're all looking at it going, can we do similar? In terms of outputs, are you going to have something that we can sort of model and take as a prototype?
Yeah, I think as far as releasing the code behind that, we'd be very happy to do that and share that. Obviously, there's a cost associated with calling the APIs. So when you're doing your own instance of that, you would need to put in your own key for that value. But we're very happy to share the technology behind that.
Thanks, Jenny.
Just on that though, the cost is actually not that much. I think we only spend a few dollars literally on the processing. It's not.
Compared to having people have ChatGPT subscriptions, it is you can process 1,000 catalog cards with only a couple of dollars cost with using OpenAI APIs. So it's a lot cheaper if you will have lots of people trying out different systems and or wanting to process things in batch. It's quite good for doing that.
Thanks, Jenny. I'll move to a related question. So, Regina, apologies. Which foundational model is being used, and why did you choose that one?
I think that there are a number of different models being used. For the hub, you can select what if you're looking at large language models, you can select that. For the individual custom models, I believe, talking to Wallace, he started out with a small data set, a small model using Olama, and trained that was already recognizing some images, and then had some training on top of that in order to specialize, for example, in identifying the Aztec Tipex and other use cases. So that's how it went, how it was approached.
Yeah. The demo that you showed with the AI hub, this is to pick up on Rob's question. Can we access that, or is that just for your staff or your researchers, or for people that you've kind of opened that up to?
At the moment, we're just using a small set of people to understand use cases and to try things out. So they're within the libraries and museums group within Cambridge right now. But we'd be interested in kind of sharing the technology behind it and getting people to try it with their own setup. And that I think is the best way to share it forward.
We could possibly think about a sample account for a few days if people are interested in trying it out, Jenny. But talk to us after if people are interested.
Yeah, you might get a lot of hands. It looks fabulous. In terms of the sort of, you spoke about having a secure space, presumably on sort of Amazon Web Services. Is that something you had to? Did you pay for that out of the funds, as opposed to the sort of cost for using a model? Was that a separate thing?
Yeah, that's right. So it's hosted on AWS. And there's a small cost, but the application you saw is actually mainly serverless. So there's no ongoing cost to run the application. It's just, it will scale with use. So depending on how much data you're storing, depending on how much it's being used, the costs. But again, they're not actually very much. There are a few dollars, week, or I've got the exact figures, but they're quite low.
Yeah.
We had thousands of dollars or thousands of pounds set aside for the running costs in the budget, and we've barely used any of those. The major cost is the staff time and the new imaging that we've had to do. Those are the two big costs.
Did you have to go through sort of any assurance to make sure that the data was going to be secure? Did you sort of have to come up with an agreement with AWS, with Amazon?
It's not so much Amazon, it's with the AI engines themselves. So we use Amazon as a conduit, really. But when you talk to the engine, for example, OpenAI via the API, there is an option that you specifically set in there that you do not use your data for training other models. So that's the route that we've taken.
Yeah. Okay. I've got a question from Dr. Mohammed, who asks, how about old books and a session registered API tools. What are the names of the API tools? Perhaps this is about not just card catalog, but can you use the same process with old books?
Yes, very much. It's quite good at surprisingly good in a lot of cases of recognizing a lot of the old handwriting and different languages. But it is obviously best with English. But if we've done some tests with things like medieval Latin and other scripts, which it's passable, I think.
If
So
presumably.
Sorry, I was just going to say, when we had our workshop, we tried to get like a cross section of different collections and users. So we had rare books, we had really modern materials, we had different languages and scripts, and actually got for the cards at least, got pretty decent results on all of them, which I was surprised about.
Fantastic. Okay, we are going to, I think, move on to the next speakers. There'll be another chance for questions at the end. So thank you again, Amelie, Tuan, and Jenny. We're moving now to my home turf, which is the University of Manchester. And I've got two of my colleagues who are going to be speaking about what they've been doing in AI and collections, and AI and supporting the research process. So I am going to hand over first to Ian Gifford.
Thanks, Kieran. Can you see my slides okay?
Yeah.
Good. Brandon, hear me? Obviously you can hear me, that's a good sign. Afternoon, everybody. I'm Ian Gifford. I'm the head of digital development team in Kieran's directorate at the University of Manchester. And I'm going to talk today about some of the things that we've been doing with AI and collections at Manchester. But I'm also going to talk, let's see if I can get my slides to move on. There we go. I'm also going to talk a little bit about our journey as an in-house development team and how AI has impacted what we do and how we go about things. This is quite an important element of the story, really. So here's a few things I'm going to cover. But starting with the team, we are a team of 7 software developers and 2 digital comm specialists. And a few years back, our meat and drink was really fairly traditional software development, mainly web apps, mobile apps to support the digitalization of library workflows and processes. Almost 3 years ago to the day, ChatGPT appears, obviously followed by other tools. And a bit like Cambridge, we start slowly, we look askance at them for a while, slowly start to prod them. Are they going to be friendly? Are they going to bite our hands off? But we don't essentially change our day-to-day activities. But a year later, we're resituated in a directorate with AI in the title. So by this time, there's no real hiding from it. We have to tame the beast. And our fundamental role as a team has shifted, not to replace what went before, but obviously to engage with AI and help others engage with it. We probably weren't alone in the early days, spending a lot of time trying to pin down some clear, meaningful definition of AI and getting nowhere fast. We sent devs on AI courses, which of course were based on statistics, linear algebra, optimization. It's basically computer science boot camp. It was interesting, but didn't necessarily get us much closer to understanding how AI could help others in the library. So things changed really when we said, okay, we need in a sense to rediscover our purpose here. That's going to involve us not having a pristine set of definitions or graduate level knowledge on the underpinnings of neural networks, but a practical knowledge of the tools that are in front of us. So to this end, as at the time, we didn't really have any meaningful access to any institutional platforms or infrastructure for experimenting with AI. So we brought a rig, which in my imagination looked something like this. But in reality, looked more like this, because it's basically a high-powered desktop with a GPU, but something that we could start using as a testbed to really learn about large language models and small language models, as well as how they can be installed, updated, tweaked, chained, fine-tuned, etc. So along with this, we consciously adopted a different mindset as a team where we said, okay, we're now a research and development team. Our job is not simply to write web apps on demand, but to propose hypotheses about how AI could help this or that team solve this or that problem or task, and to try it out. And this has kind of been our guiding principle for the last nearly 2 years. So with that as background, I'm going to give a few examples of things we've done out of this approach. So we set out with the intention of trying to document some of our experiments on a team blog, which we created for the purpose, and which we call AI Insights. And I'll put the link in the chat, or ask Kieran to put the link in the chat so you can find out more about things that we've done at your own leisure. So the first example it came out of some investigations we did in the team looking at whether we could apply some of the techniques used in the Vatican's AI for Illuminations project to our own collections, particularly looking at the YOLO model, You Only Look Once. We compared a locally installed version of this with what you could do in ChatGPT at the time. It was quite interesting and informative, but there was a bit of a missing element. So we were doing this internally in the team. We weren't actually working with the colleagues that work with these images and materials on a day-to-day basis. So we ended up reconfiguring this as a collaborative experiment with our special collections and metadata team around applying image detection technology to support a real task. So we have a collection of early photography glass plate negatives of the Langford Brook family and a long-standing project to describe the images as metadata. So working with our metadata team, we used ChatGPT and experimented with the projects feature, which allows custom instructions to be applied to conversations. But we soon encountered a number of significant limitations. So doing it for a single image was fine. Attempting a long conversation involving multiple images caused issues, not least of which was the response time in the web interface grew significantly. Now, as I'm sure you'll know, ChatGPT is pre-trained. It doesn't learn from what you give it unless you start employing additional techniques like the ChatGPT memory feature or RAG to inject information into the context of the model. So the way we approached this was to utilize the OpenAI APIs to create a new conversation for each photograph. And this enables you to have more control over the context as well. So then we used an open source face detection model called DeepFace using our rig to identify faces and then fed this information into the conversation as context, which resulted in much more useful and accurate descriptions. So using the APIs also helps address issues of scale and automation, as much as the promise of the technology is around saving time and effort. But another challenge we faced was around the fact that this is early photography and the images are black and white. They have contrast issues. And so despite the added context, ChatGPT still often struggled to actually identify faces. And I think ultimately we only got about a 50% success rate. So this work is very much ongoing. And things have improved each time ChatGPT released a new model. Things seem to improve slightly. But we're also continuing to investigate combining additional bits of contextual information through the APIs, such as common information about the family and individual photos with human-authored descriptions to see if it improves things. The second example I'd like to share is another collaboration, but this time with a researcher. So we have a digital edition of the Mary Hamilton papers in our Manchester Digital Collections platform. They're beautifully written letters by an influential diarist of the late 18th century. And one of the main features of this edition, as you can see here, is its rich, marked up transcriptions of the letters. But it's not a complete set. Only about half the letters have been transcribed to date. So we thought this might be a good candidate for exploring fine-tuning using our rig, as we had an excellent set of training data in the initial set of transcribed letters. But we could potentially also benefit the researchers continuing to work on transcribing the remaining letters. So we experimented a bit with some open source models like Llama and Gemma, and we found they're actually pretty good at HCR, so that's handwritten character recognition, at least for reasonably neatly written letters. So where the fine-tuning actually had more of an impact was on understanding 18th century conventions and abbreviations, on controlling the output. So as you'll see here, we actually discovered there was an optimal set of training data, which was around 50 letters. So between 5 and 50 letters, there was continual improvement. But beyond 50 up to 100 even, it didn't actually improve in accuracy all that much. So we presented this back to our slightly skeptical academic, where possible, aligning the transcribed text to the actual image for them to review. And he was actually really impressed with the results, and obviously wasn't going to affect the academic rigor with which they transcribed the letters. It provided an incredibly useful starting point for them. And even only over the last week, they've contacted us asking to see if we can transcribe a further batch of letters for them. So we've also learned a lot in the process, and our developer who worked on this, Pete, has detailed this in a blog post, and we're continuing to think about how this could be applied to other collections, but also how it might compare with existing paid tools that do similar things like transcribers, and with ever-evolving general-purpose models. So, for example, we've heard there's a new version of Gemma recently released, which is supposed to be good at transcriptions as well. So another approach we've taken to exploring AI is looking at whether AI tools or functions can be embedded in or utilized within existing software applications we support. So the first example of this is we help maintain the open source software application for email archiving, appraisal and preservation, EPAD. So being large textual archives, we thought there might be an opportunity to use a large language model to possibly assist curators in the appraisal process. For example, by helping them to identify specific content that might contain personal or sensitive information, or using sentiment analysis to find emails that are emotionally charged, or to categorize them by personal or business conversations. There's actually some primitive AI already built into ePad that does something along these lines, but it's very limited and very outdated now. So we did some experiments creating an interface to hook ePad up to an external AI, and we've tried this with both ChatGPT and with open source models running on our local rig. This turns out to be a great advantage because email archives tend to be closed archives, and our rig can be safely isolated from the internet. But we're also working with our creative arts archivist for her guidance on what sort of prompts would be most useful to support her role. So we've tried a few things. Things like sentiment analysis don't always turn out to be that useful, but understanding where information contravenes data regulations like GDPR can be useful. But again, the question of feeding in the contextual information becomes quite important. Interestingly, simultaneous to us doing this, the National Library of Norway were also looking at adapting ePad because the inbuilt lexicon generation feature, which was AI-based, doesn't work very well with Norwegian language archives. So they've kind of plugged in an external Norwegian language model to generate the lexicography and then fed that back into ePad. So it's this kind of a similar model, I guess, in terms of embedding AI into these applications. So the second example came from a research project on our Dante collection, where there was a requirement to embed an external AI tool that compares images into our digital exhibitions platform based on AmikaOS. So the external tool was developed by the Oxford Visual Geometry Group, who are a specialist in computer vision. But after discussions with them, rather than creating an integration specific to one particular platform, we worked together on enhancing their software with a view to creating a web component version of it that can then be plugged into any web-based interface. So this is a highly configurable component. Now, here's a few examples of the different visual modes it supports. There are plenty more as well. I like this because it's a great example of how we as developers can play a useful role in helping to make more specialized AI tools useful for a wide range of people and applications, as anyone can now utilize this within their own web interfaces. So, although much of what we've done has been targeted experiments working with specific individuals or applications, we've also been thinking about the bigger picture as well. What do we need to do to get our collections data into a state and place where it can benefit from AI at scale, whether to support ourselves managing collections or to enhance discovery and dissemination? So a couple of things to mention here. Our current ecosystem of collection systems and platforms is, to say the least, a bit messy. We've procured a number of different systems over the years for particular teams, not always with the views of how things fit together and integrate technically, and with a range of different metadata formats and standards being used for different purposes. So we are now running an internal project called Recollect, where we're basically doing a root and branch review of our existing collections platforms, performing usability testing, gathering new requirements, and basically taking stock to ensure that whatever decisions we make in the future take into account the AI paradigm and ensure our data isn't left in silos and can be linked and merged with other relevant data to reap the potential benefits of AI. Alongside this, we've also been partnering with a Canadian company called Terentia, who have developed a flexible cloud-native DAM system for the GLAM sector, and who have been part of a Microsoft Fast Track program looking to embed AI tools into native Azure-based solutions. So we've worked closely with them to bring together a sample set of data from across a subset of our various collections platforms into Terentia, and they're currently working on ingesting this into a sandbox for us to experiment with and review. So it's a proof of concept, but it's a practical one to help us envisage what working with our data in a cutting-edge solution which has AI as a foundational element might look like. So I just wanted to end really with a few thoughts and kind of provocations and some of our lessons learned. So starting with some of the pros and cons of having a dedicated rig. On the plus side, it's enabled us to build a small number of specific services based on AI. It's supported a large number of learning, training, and knowledge sharing activities. It's enabled us to experiment with things like chaining and fine tuning, and to compare and contrast the characteristics and efficacy of different OS models. But on the downside, we're restricted by size because it's basically a single GPU. We can only run a certain number of models on it. We can't really use it to productionize services at scale, as it would require a service management layer to be built onto it. It's also a bit temperamental. When you update the underlying software or do new installations, it can throw the whole thing over at the drop of a hat. Another point I would make is that since we brought the rig, the University at Manchester has caught up a bit on the provision of AI platforms. So we've some limited access to Copilot 365, tools like Amazon SageMaker, and a few other tools as well. And these are great tools for playing around with, for learning, for knocking out proof of concepts. However, they're not always set up to to enable the systematic production of AI-based services. And this is understandable from a certain perspective, because you don't want people to spin up business critical applications at the drop of a hat using these tools without some proper scrutiny and due process. And there's rightly a lot of concern over what data people are putting into these tools, questions around environmental sustainability. Yet it's kind of also a bit of a barrier to teams like mine that would like to develop reusable, stable and secure services and don't necessarily have access to systems that fully enable this. So I've started to call this the kind of everlasting sandbox syndrome, which I think can, in some senses, limit the benefits of AI unless we kind of can break out of this into ways that we can provide stable services. And then my final observation really is around the challenge and opportunities of vibe coding. So this is where people without knowledge of how to code just use AI tools to do it for them. And this has naturally come up with us being a development team. So the horse has bolted in many ways. We know we can't stop people from doing this. So we've actively tried to support and even encourage people who have discovered this ability to code with AI without any knowledge of software engineering principles or practice around design, testing, etc. But there's obviously a balance to be struck here. There are some well-known cases now of AI coding tools deleting production databases and then saying, whoops, sorry, didn't mean to do that, shouldn't have done that. So there's a role for developers really in mentoring, supporting others to use these tools effectively, while also warning people to maybe not be too gung-ho or over-promising or over-expecting. So we've got some great examples of people using it effectively for personal productivity, and it's been really useful for people without coding skills to design mock-ups or prototypes to show what they want. But it can also create false expectations when someone builds an impressive looking demo which can't be implemented because maybe it doesn't conform to institutional technology stacks or standards, or because the person who built it doesn't fully understand what it does, or maybe even has left the organization after building something. So the devs in my team themselves, they use AI, selectively and cautiously, I would say, in their own coding work. Is that one or two don't like to use it at all because it slows them down, having to constantly check through generated code, which generally isn't, as they would have it be. So, but that's very much an ongoing conversation that I think organizations are going to be faced with. So just to wrap up, a word on a few upcoming areas of work. So we're running a project now called RLUK Cloud, which is broader than AI. It's partly about how we can utilize the cloud for other things as well. But there's a key part of it will be whether we can utilize cloud services, things like Amazon Bedrock or Azure AI Foundry, to help some of these issues around productionization, provide provision of stable, secure environments for AI services. I've already mentioned Recollect, this kind of holistic review of our collections ecosystem. We're hoping to undertake some further collaborative work with the Visual Geometry Group and working with them on some of their other computer vision tools, particularly those involving image annotation. And then finally, we've started an internal project to investigate the impact of AI because on changing user behaviors, because we've got a growing body of evidence now that it's beginning to significantly impact engagement via traditional channels such as the web. And we want to kind of make some time to explore this more deeply. So on that note, I'm going to stop and hand over to Scott.
So yes, it's the final case study of the afternoon is on the topic of green open access and how we've been exploring ways that we might transform this form of open access through the use of large language models. We are at the very early stages of our work, so this is by nature a more conceptual overview, certainly compared to the other talks this afternoon. Confession, I did have my original slides ready earlier this week, but I sent my notes through a tool called Google Notebook LM, and it created some rather snazzy slides that I just decided to use instead. So I ditched my original slides and I'm using these AI slides, which is apt for the topic of today. So this first slide is a deliberate provocation and the most probably pessimistic take on green open access, but I think it's useful to help frame the issues at play here. So we've had green open access for about 20 years now, where authors archive, they self-archive the accepted version of their article in a repository. I think the term was first used in a blog post by Stephen Harned in the early 2000s. It's been an essential route to openness and is a good thing, but has always had its weaknesses. Historically, the embargo period was the big one. You had to, you could only share your accepted paper after a 12-month or 24-month embargo, and that was a bit one of the big obstacles to green open access take up. But also, Green OA has always lacked the consistency of the published version of record. A green open access paper might come in a variety of file formats. It may be at different stages of completion, despite what the authors say. Figures and charts and tables may be missing. Erratum, addendum, or retractions may not be applied to the Green OA version. But crucially, it is completely unstructured data. It's a Microsoft Word file or a PDF that has no internal structure. So we say it, when I'm saying here it's open in practice, in theory, but invisible in practice, I mean the content of the Green OA manuscript is invisible to a sense to indexing services, because the contents of the manuscript have not been structured. So there's a utility and a trust issue that's always been inherent with Green Open Access. In contrast, the publisher's version of record is very often highly structured in terms of the contents of the articles, so, because the publishers will transform the accepted manuscript into semantically rich, machine-readable JATS XML, which is the sort of industry standard. And this supports really powerful data exchange, helps with the indexing of those articles, and allows for really attractive presentation through transformation into HTML web pages, which we're familiar when we go to a journal web page. It looks nicer than an institutional repository record. So this is not something the library sector has ever done at scale. We don't turn AAMs into XML. We never have. We attach a file to a metadata record and we create the metadata record itself, but no more. But there's been two developments over the past sort of 2 or 3 years that may change that. The first is legal and the second is technical. So, and this really makes it possible to ask ourselves, what might it look like to create a semantically rich, structured representation of an AAM? The first change, this legal change, is the emergence of rights retention policies that automatically assign the right to universities to share AAMs immediately upon publication. That's written into the policy. So here at Manchester, we introduced our own rights retention policy along with the rest of the N8 universities a couple of years ago. So we no longer have to apply these varying length embargoes on the university's articles when we share them through our repository. So there's a major shift on the sort of legal policy side. The second key development is, of course, and most relevant to the topic of today, is the emergence of large language models that are developing their capabilities at an accelerating pace. As we've heard throughout all of the talks today, one of the things that LLMs are very good at is taking text and transforming it from one format into another. So it could take an unstructured block of text and produce a highly structured version of it in a standard such as XML or JSON. And this opens the door for us to explore whether we could transform an unstructured AAM, which is in a messy Microsoft Word file perhaps, into a highly standardized structured representation, such as that the publishers typically create. So at Manchester, we've been exploring this concept, and we spun up a project which is asking precisely that question. We're exploring whether LLMs can be used to create JATS at scale. So quite a lot of the early work of the project has been focusing on getting the legal sign-off to pursue this idea, which we have, and getting the senior university leadership approval, again, which we have. And doing some early proof of principle work to test the assumption that large language models are capable of creating JATS XML. So in the new calendar year after Christmas, we are planning to begin more serious development work to allow authors to ultimately, with an aim of around summer 2026, allowing the first authors to opt into this option where we take their AAM and take it through the process to convert it into JATS XML. So, as I said, libraries have long experience when it comes to the metadata around the article. What we've been internally talking about this is the inter-article metadata, the journal, volume, issue, DOI, authors. We create those metadata records for the journal articles we manage, but we have not ever done anything when it comes to the contents of the articles. So applying structure to the contents of an article Involves identifying the different sections of a paper, the introduction, the methodology, the discussion, and then identifying the references and figures and charts and tables. In terms of green open access, that's always remained a sort of dark matter. We don't. It's a file and no more. And that's the area, that's the space that the project is in. Can we mark all that information up? Can we pass it out of the AAM? So, and that's a challenge. That's huge. I mean, no machine learning NLP sort of approach has come close to 100% lossless extraction of that sort of information, and that is the aim. So this is not really a solved problem, but nevertheless, that's the problem space we're working in. In addition to the elements that a publisher might apply structure to, we also may wish to apply structure to other aspects of the paper that may be more aligned with our own institutional strategies. So there may be information about collaborations and reproducibility, impact, commercialization that may be in the paper that we may also want to explore passing out. So there may be information about equipment that has been used in the article that it would be useful for us to identify and mark up, so that we can then look at across the collection and see where perhaps that equipment has also been referenced. So and then that opens up all sorts of possibilities around demonstrating impact, and that's just one example where the publishers might never mark up that sort of information, but we may be really interested in that. So huge potential for additional markup here. So our early exploration in the second half of this calendar year has suggested that the best way to approach this is to have a metadata specialist at the center of the process. Give that person access to the environment and the tools to incrementally build up the XML. So really build up that XML in conversation with the AI, with the large language model in an incremental way. So copy and paste specific sections of the article into the model, tell it what the XML authoring guidelines are, and gradually build that up. That seems to be quite a fruitful approach. Rather than have the LLM just produce the XML and then look at it afterwards. So that's the model that we're sort of pursuing. A key element, a really critical element of this work is the schema that we choose, or sets of schemas that we choose. We're currently looking at the JATS schema, the JATS, Journal Article Tagging Suite schema, because primarily this is the standard that's used by the publishing industry itself. But there may well be additional schemas we might want to look to adopt. There may be information that JATS isn't really best suited to start. And this work is being progressed through an N8 working group, which is one of a number of working groups that have been established as part of the N8 statement on equitable and sustainable publishing. I have to pause at this point and apologise to Sheffield and Lancaster. The AI created an N6 image here, which is a good warning not to rely too heavily on AI outputs at this stage. So the big idea really underpinning this project here is that the next generation of an institutional repository is not necessarily one designed only for human users. There's a fair chance that an increasing proportion of use would come from AIs. So creating a machine-readable collection of the university's research collection would position us well for this version of the future. So you could imagine the collection being loaded into an LLM's context window, or through new protocols such as the model context protocol, loaded into an environment for further analysis. And this model really, the affordances of this structure really allow for that. In addition, there may be other areas that we want to explore. There are a great many teams across the university that we work closely with, and individuals who could further enrich the article record in really powerful ways. So down the line with this model, we could imagine a network of data stewards, impact officers, knowledge exchange colleagues, and our comms teams, all positioned to enrich the structured data even further with information that only exists within the organization and a publisher would never have access to. And in addition, another key avenue that this opens up is to enable really powerful analysis. By applying bibliometric techniques, we can help the university answer questions about itself in ever increasingly powerful ways if we have all this structured data and not necessarily relying on commercial citation indexing databases. So one of the ideas as part of this work is we would explore loading this information into our data lake, emerging data lake environment for wider access and analysis. So to conclude, as I say, this is a reasonably conceptual piece, certainly compared to the other talkers today. But this approach may well represent a next phase for green open access and has only been made possible because of the emergence of these powerful large language models. So I will, at that point, stop sharing and say thank you.
Super duper. Thank you, Scott, and thank you as well, Ian. So yeah, do post your questions in the Q&A. You can find the button down at the bottom. We'll kick off, and this one's for you, Scott, and I think it's come from William of RLUK fame. So Scott, is there any potential for you to enhance those institutional records, the research papers, the output, with the credit roles taxonomy, potentially pulling out that data so that you can attribute credit for those for all the research output of the institution?
Yeah, absolutely. We've priced that in to our XML authoring guidelines, and it's a great example of how we are sort of potentially limited only by our imagination in terms of what we extract out of the paper. There are standard schemas like credit that we absolutely should look at, but there are these other sorts of more bespoke areas that may only be relevant to within the organization, may be relevant beyond. But credit is a good example of something that we may not always get that information from the publishers, but we can certainly look to produce it ourselves.
And just to follow up on that, have you thought about to what degree are you going to hopefully break the information down and put it into JATS format, and then presumably have some kind of interface for the world and for researchers, versus maybe programmatically making it available so people can almost, plumb in and use that sort of corpora for their own research?
Yeah, I think as we're in the early stages of the project, we've built in various staging posts and gateways, and one of the early gateways will be to share the XML through an API. So we would enable programmatic access. In parallel, we will be asking ourselves the question around a front end designed for humans to view the research outputs. And again, this allows us to present that in all sorts of different ways that we can't currently. We're limited to really a file attached to a metadata record. So these are all things that are planned to sort of be decided upon in the project.
Thanks, Scott. I'll sort of take chair's privilege and ask Ian a question. So Ian, you took us through the journey of your team, sort of starting with AI, what is it? And then exploring, upskilling, getting the rig. You're now kind of moving into the cloud, sort of mirroring a bit what we heard from colleagues at Cambridge. What's the plan after that? Where sort of next, once you've explored, where do you think that might take you?
Yeah, we don't entirely know, really. I think a part of it is there's this tension between what we want to do and what platforms we have available as an institution. And like I said, I think it's great to see what Cambridge has done. They're further along, I think, in terms of their ability to utilize some of the, the standard cloud offer like AWS, and obviously at Manchester, we're kind of a little bit behind, but then there has been this emergence, I think, of support within our central IT services, looking to kind of support people that want to do this more. So I think one of the key questions for us is, well, there's a few questions, isn't there, around, but the costing, is, I think a few people were asking about how much does this cost. It's really interesting to say here, Tuan and Jenny, so actually it's not, well, we kind of factored in some quite hefty costing for this, but actually it's turned out to be fairly cheap, because in my mind, one of my concerns about this is once we do get something to the cloud, is this going to cost us the earth to actually do this? And it sounds like probably it isn't. I mean, I suppose it depends on how much data processing we're doing. So that's one aspect, and the other one that came up was around the security of it, and the idea that you can have a safe space where data isn't going to leak out onto the internet, because that's something that we're kind of dealing with as well. And one of the advantages of having our internal rig is we have complete control over that. We know full well that it's not going to be cut to the internet, and that's been particularly valuable when we're doing stuff like the email archives, because there's some very, very strongly sensitive data there. But it's a mixed view, and I'm not really sure yet. There's different ways you could go, and different areas that you could invest time and effort into it in terms of that local infrastructure versus cloud infrastructure. And we're still working our way, I think, in terms of what the right strategy would be in terms of doing that. But I think certainly for our cloud project, I would like to kind of move in the direction of what Cambridge is doing and starting to use some of those out of the box models, because we've been installing open source models because that's what we've got access to. But obviously Textract and the other stuff that Amazon can do, that's equally applicable to use cases that we have in the library as well. So I don't know. It's all kind of feels like a big experiment still at the minute. I think hopefully in a year's time we'll have maybe moved more in the direction of using some of these cloud services, and we might be able to compare and contrast how that looks against having a reasonably powerful desktop that actually can do maybe some very specialized tasks, but do them really well and in a secure and sustainable manner. So I don't really know is the kind of answer, but it's going to be fun finding out, I think.
Absolutely. No, it's going to be a roller coaster ride. Scott, your project concept is potentially quite disruptive. It could be to the publishing process, and I think despite its issues, which I think are sort of well documented, our research colleagues are sort of part of it, whether they kind of want to be or not. How are you, or have you thought about how you're going to sort of take researchers along on this journey in relation to the Manchester Open Research environment?
Yeah, I mean, I suppose it's hard to say at this stage. It's hard to predict the future. One of the things we've decided early on is that any rollout of this would be based entirely on an opt-in model. So we have an interface which we call the Open Access Gateway, where authors share their manuscripts with us for us to sort of ensure they're compliant with REF and other policies from funders. And we would ask the question there if they want to opt into this exploratory, experimental, would make it sound like a lab sort of thing rather than something that's production ready, maybe. But then nothing again would be shared publicly without the author's sign off as well. They would see the final extracted version. So we would mitigate the risks in two ways, through those mechanisms. But then hopefully we would be able to demonstrate, we would be keen to measure the benefits in terms of visibility and citation and reuse, and they would start to speak for themselves in terms of encouraging a wider take-up of this model.
Thanks, Scott. Have we got any other questions coming through? Yes, we do. Okay, this next one's for Scott. So yeah, obviously licensing could get in the way if you're not just aiding discovery, but if you're re-representing the content, even by using CC BY, how are you navigating the sort of the copyright jungle?
Yeah, this is the there are many different sorts of problems with this project, and there's technical problems and cultural problems and there's legal problems. Problems perhaps is not the right way of framing it, but issues to overcome. And yeah, the legal side of it, we have spoken with our legal team at Manchester about this creation of derivative works based on the CC BY assignment that we have through our rights retention. And the advice was that this is within this would be fine within the rights retention policy that we have to create that version. But at the same time, this will be new, and it's not without the risks. of the publishers pushing back on this. So yes, the risks are there.
The risks are there, absolutely. Well, yeah, good luck with that. So Ian, your team have been working across the library. Have you found any challenges with working collaboratively with teams who perhaps are not in that same place when it comes to generative AI and AI more broadly?
Well, yeah, good question. I think we pick and choose our partners fairly carefully with people that are more on the kind of, that are interested for their own purposes, really. I think that there's a natural kind of resistance in some areas. I think, and that's, we don't see that as a bad thing. I think as a sort of healthy dose of skepticism isn't necessarily bad in these things. But it's been most fruitful, I think, where I think particularly on in the special collections team, the people that are doing a lot of work with that metadata, generation from archives and images and things, they're quite keen to understand the benefit it can bring to them, and I think in some ways more aware of some of the kind of risks around it than we are, with our focus on the kind of platforms and the technology. So I think this was a point that Amelie made, that the knowledge is sort of spread around, really, and the important thing is to kind of bring it together so we can kind of collectively make the right decisions about, and choices about where the tools benefit people. But one of the nice things that we've done is, I think, everything we've done is provide something that's assisted, a human doing something that they probably could have done without AI. So there's not been the sense that anything's being replaced or it's a threat in any way. But and I think when people have seen the benefits that it can bring, that kind of makes them more willing to then utilize some of these tools in reality. So it's the most satisfying thing is just like with the transcriptions thing, because we can do it and just show it to somebody, and they could have just sort of said, well, great, but I don't really want to use it. But actually they've engaged with it and said, you know what, this is actually really helpful. Yeah. And that's, gives us sort of encouragement, I guess, to keep going and keep finding more use cases that are relevant.